So hi, my name is Andy. Today I'll be here talking to you, and I'm so grateful to get this opportunity. It's really great to be here to celebrate 10 years of Presto and be here in person at PrestoCon. One thing, before we get started is speaking in person is pretty awesome, but for someone who works in tech and lives in the Bay Area, a lot of my other friends not in tech, they go places, they go to Hawaii, they go to Paris. I roll out of bed into my Toyota Camry, and 20 minutes later, I'm here. But nonetheless, really excited to speak to everybody today. In particular, I'll be speaking about customer-facing Presto at Rippling. Well, OK, there we go. So I'll tell you, of course, about our use case here, but I also want to take you on a journey about how we're really a hyper-growth startup right now, and we don't have so many resources to put towards open source. Personally, I also had limited experience with open source as well, and I want to encourage you and also see how the open source community has enabled us to really work with them here. So first, I just want to make this really clear. I work for Rippling. We're an employee management system and platform. I know a lot of people get us confused with cryptocurrency, and I don't blame you. Even Google search thought that for a while, but really what we do is employee management. And the big idea here is that we connect everything that deals with employees in the management from HR to IT, and we really unify all that as a single source of truth, as a single platform to unify all that together. And in particular, one comparison we can make here is between Salesforce, for example, working with customer management. With their CRM, you have an integrated set of data that has a various series of extensions, applications, et cetera. And what we're trying to do is the same thing, but for employees. And so you can imagine this can look like automations, provisioning, access, as well as various third-party providers that extend our abilities to manage your employees from things like time off to payroll and stuff like that as well. But at the center of this, we see ultimately sits the database. And there's ultimately data that has to power every aspect of this platform. And so how does this actually work? So at the core of this all is a data platform, one that unifies both pieces of HR and IT and a series of functionalities such as workflow automation, analytics, permissions, and also policies that ultimately enable our customers to really interact with this platform. And so you can see, for example, customers can ultimately access these various data points and connect them and utilize them in different ways to gain power through our platform. And one of the ways they actually use us is through something I work on called RQL, which stands for Rippling Query Language. And RQL is a SQL-like language, scripting language that we expose to our customers to give them the ability to sort of write custom functionality that drives their different workflows, automations, et cetera. And so in this case, for example, we can see that we want to generate maybe a custom field for a report. And one thing we're curious about here is what is the average pay for a given employee? Our customers can write RQL formulas that define the sort of calculations they want with their own custom logic. And that gives them the ability to really utilize their employee data across our various connectors, across our various data sources, and utilize them across the platform as a whole. So the question here is, how does this all work? And I'd like to say, we built this with really scalable designs in mind and whatnot. But really, we are a startup, and we were going through a lot of growth. And so what mattered to us at the time was product market fit. And so, for example, we ultimately needed the following pieces. First, we need to take our RQL formula and be able to interpret what that actually means in our platform. After we have that interpreted, we have to be able to execute that against our storage system. And so the formula on the right here from the screen before, it will be first compiled in some way so that we can actually interpret the strings that this represents. Next, this has to be executed across our data store containing our employee graph data, which is ultimately stored somewhere. And the first version of this was designed in a way that was quite coupled to the system, coupled to the abstract syntax tree, which is how programming languages or even SQL can be interpreted or run. And was really built for product velocity at the end of the day. And so the first layer is converting from our domain-specific language to an AST. To execute that, we have custom code writing some recursive load and function to ultimately execute against that, running on our product databases. And there's a lot of problems with this that I don't necessarily even have to mention, but here's a few of them. One is scale. To scale across the system where we're running against, for example, our product database, or running against our abstract syntax tree that we're constructing with our own custom logic, is a really difficult problem to scale up when we don't have a lot of the optimizations that databases do. There's a lot of bottlenecks we experienced here because we didn't have a lot of this, and we had limitations on what sort of queries we could run for our customers and what they could ultimately perform here. Federation, we couldn't ultimately query across a variety of different data sources, and we were really stuck with our product DB, whereas various other data sources may make sense for given use cases. And finally, coupling was a really big issue here. We had, our entire system was so custom written from our RQL statements all the way down to how it executed on our data sources that we didn't really have an easy way operationally, and maintainability was also going to be a huge issue in this regard. And so the big question comes up in engineering a lot of times is, do we buy or do we build? And there's benefits both ways, and this is definitely not a complete list. There's a lot more that can go here. But one of the big reasons we decided to build the first version of RQL was that we really needed a lot of custom support for how we wanted our language to be interpreted, and the sort of optimizations we needed to power our product. At the same time, though, there's a lot of engineering investment that was put in, making small changes in optimization, really just small nitpicky details. There's bugs, and there's a lot of things that are difficult to keep track of. At the same time, many startups will go towards the direction of buy, where you have something that's managed for you, and that's really nice. But you do have some feature limitations in this regard, where you have to wait for stable deployments and stuff like that as well. And so what open source really provides for us is this ecosystem of options. Open source has been a really great intermediary for us between having to build completely from scratch or buy a complete product. We needed the flexibility in our case because we have a very unique problem in some regards, but at the same time, we have a solved problem. In a lot of ways, these technologies enable us to build upon the work that has been done before us, but at the same time, also build on top of them to enable our particular use cases here. And so we had a lot of options to choose from here. But ultimately, what we went with here, and we'll go through here in a bit. The first piece was from our compilation stage. Instead of having to use our own AST compilation from our RQL statement, that was mentioned in the keynote today morning that SQL has been around for decades. It's been stable, it works, it's trusted, and it makes a lot of sense for us to go, let's use SQL. It's a very stable interface that we can really utilize and take advantage of here. The second piece here was instead of writing our own query execution and database internals to some extent, we switched over to Presto. Presto gives us a lot of flexibility in this case to support a lot of different use cases and a lot of data sources. And we're really excited about the changes coming to Presto that will enable this at even higher speed and more use cases as well. And finally, another piece here is that from our product databases, we've switched to using Apache Pinot and are building upon other connectors here in the Presto ecosystem that enable us to really go for various use cases. Apache Pinot is a real-time OLAP system that allows a lot of very fast real-time querying at scale. But there are many use cases which don't necessarily fit into this bucket, and that's where Presto can really enable us to use various different databases as well here. And so what do we get with this new system ultimately? Well, we definitely get scale. At each step here, from SQL to using Presto to using Pinot, we know that ignoring that SQL piece, all these other parts are horizontally scalable. They're really built for scale at very large companies that have been tried and tested. And we know that it works pretty well without too much fiddling with. Secondly, federation. We want to use Presto as a one query layer to really hit a lot of different use cases to power our platform. Presto enables us to use Pinot to start, but also to connect to various other databases as we continue working on this. Decoupling. There's a pattern, with startups as they go to big companies. You go from a monolith up to microservices, and then once you're too big, you also want to go back to a monolith again. Likewise, here, we really have this decoupling pattern as our company scales since we're going through the hyper-growth phase right now, we're really trying to go from sort of this monolithic pattern into how do we isolate our components here so that we can operationally run faster and more efficiently as well. And lastly, of course, it's open source. And the benefits have been numerous, and they've been discussed by my speakers before me. There's so many opportunities and sort of doors that open up with using open source. And the community is a really powerful tool with the rest of the ecosystem here. And so here's just a quick look of the basic high-level idea of how we're using Presto. Pretty standard sort of architecture. We have some upstream data sources being fed through Kafka into Pinot. And so you can imagine this being CDC, various different product data as well, and various other data sources. And through our querying end, we use Presto to hit Pinot and other data sources to sort of construct our query results here. And really, this is where open source has become really powerful for us, is that we have a lot of custom functionality that Presto didn't support right out of the box. There's a lot of support in Pinot that didn't support what you needed right outside of the box. For example, Pinot, using their V1 engine, doesn't actually support joins. But as my previous colleagues at Uber have done, there's been a lot of work really connecting the use of Presto and Pinot to get the best of both worlds. ANSI-compliant support alongside the real-time OLAP, really fast execution engine of Pinot. But one other thing here was that we didn't have a lot of the C features we wanted and needed to support an arbitrary customer query coming in. Because we allow our customers to write so many queries, they can really query with a bunch of little edge cases we need to consider, a bunch of data types, a bunch of functionalities, where a standard analytics workflow at a company might not support. And so, for example, I'll talk through some of the contributions we made, but we needed support, for example, for nulls in Pinot. Pinot would go with default values instead of actual null value, for example. Or we would realize that our particular use case varied a lot from other companies that are running this at high scale, analytical workloads that were very internal to, for example, for BI or whatnot. And we realized that we had to adjust our use case and adjust the platform in a way that we could control. And so this quote from Linus really illustrates the fact that with open source, we did have control of our destiny. We could control sort of the direction we wanted to go with Presto. But that being said, open source can be daunting. So who in the audience here has contributed to open source? So there's a pretty good number of you to be expected, of course. But who here hasn't contributed to open source but really wants to contribute to open source? See a couple hands here and there? So one of the reasons here is that open source can really be a daunting experience. And it's a code base. No one in your company really maybe knows what's going on, like was the case for us. And you're tasked with seeing this giant project that's been going on for a decade and say, how do I actually get into that? How can I start exploring that? And how do I actually use this to our benefit? And so, not to brag or anything, but I did contribute to Pandas back when I was a student in 2015. But this is what it looked like. There's a couple grammatical changes here, a couple of spacing and formatting changes. And this is my foray into open source. And yeah, this is pretty ridiculous. I'm a little embarrassed to share it here, actually. But this is where I started, and because I didn't really know how to navigate a code base at the time. And so I get it. It's daunting. It's hard. I didn't know what I was doing going into Presto. And when I started with Presto, it was just listing out various different configurations. There's hundreds and hundreds of them, different ones for different connectors, and it's overwhelming. But one thing I'll say is that with open source, anybody can contribute. There's a lot of ability. Every piece, even small pieces here and there, anybody can get started and really contribute to the ecosystem. For us at Rippling, we're a hypergrowth startup. Our team isn't that big. We've really had a lot of components in our system here, but we needed really custom pieces here. And we came through an intermediary where we could use Presto, with a lot of the functionality that we wanted, but still contribute the pieces that we realized we needed here. And so our philosophy here was that it's driven by our business needs, what we actually need to implement to execute our project. But ultimately, we can contribute this in a way that benefits everybody, in a way that benefits the ecosystem. And they've worked really well with us to help us deliver what we need. And so what does this actually look like for us? One thing here, with my former colleagues at Uber, they did a lot of work on aggressive pushdown and making sure that, that a lot of the queries from Presto going to Pinot push down as much as possible into the connector so that Presto minimizes the amount of work it has to do here. We contributed a little bit more to open source, doing work on projection pushdown and filter pushdown, working with special forms and string functions here. Special forms being the Presto terminology for things like case statements, coalesce, et cetera. And one thing here we really focused on was projection pushdown. Because for most companies, if you're adding a transformation on data you get after the fact, you don't really care where that happens in the layer, right? It doesn't really matter if you're processing something after the fact in this case. But for us, it became really important because we had a lot of custom functionality that our customers would write complex SQL, what would ultimately get translated into complex SQL statements, that we really would end up saving time, for example, pushing down coalesces on multiple columns. Whereas before, maybe we could just leave Presto to do some of that work. We made sure that we could utilize the best of both worlds here by allowing Pinot to take control of some of these pieces. For example, other things we made sure to push down were like, we commonly have string functions. And string functions, for example, if they're not being used, if they're not being pushed down, means that Presto has to do a lot more data fetch, and we're not able to take advantage of Pinot's indexing and the knowledge that Pinot has to really filter out the data. And so really, by contributing some of this that benefits our ecosystem as a whole, we also get major performance gains on our side as well. And then but this also we saw other bottlenecks as well in the work we were doing. And one piece here is around dynamic filtering pushdown. And so dynamic filtering, for those of you who might not know, is really unique to the sort of distributed data platform that Presto provides. And one piece where this is really important is the fact that in Pinot's V1 engine, we can only fetch one table at a time. We can only take we can essentially only do one scan at a time. Any joins that have to happen between two Pinot tables are happening within Presto. And so what will happen, for example, is if you have a table scan, for example, here we're joining an employee table against this company table here. This inner join, for example, here, what Presto will end up doing will scan for all the rows in company and all the rows in employee, and will be responsible for joining both of those together with full data fetch from both of those tables. In the case where we do a filtered scan, Presto will filter the data, for example, before it reaches the join stage so that the amount of data we're actually processing decreases here. But you can see with employees, we're still doing the full data fetch here. And this is quite expensive if, for example, there's no condition that ultimately can filter down the employee table explicitly. What dynamic filtering allows, which is a contribution that was made to Presto quite a bit earlier, was that it allows us to actually filter out the data before we reach the join stage so that we don't have to join as much data even if there's not explicit filters. Using the knowledge it has from the company table and the company filtering, we can see that instead of filtering instead of us having to choose all the employee data, we can now say that we will only send out all the employee data that is actually filtered out with companies from our company table. So we can substantially decrease the amount. In this case example here, the data that will end up being joined against is ultimately just the employees that work for companies in San Francisco, for example, here. So ultimately, the amount of data we're sending is less here. But there's still one major issue. And that issue here is that we're still doing this full table scan on the employee table. After the fact, Presto is reducing the amount of data that actually gets joined against, but that doesn't change the fact we're sending over there's a lot of I/O and a lot of load on Pinot by doing this full table scan here. And so that's really where dynamic filtering pushdown comes in. And so with the probe side here of the join, what actually happens is that condition for the employee filter or the employee company filter gets passed into the connector here. And so no longer are we just saying we'll filter the data after the fact. We're saying from the first fetch, let's not fetch all the data. And so in this case, we can imagine that if our employee table, let's say, is 10 million rows, we're essentially fetching 10 million rows before we process any filtering here. Whereas let's say we have maybe 100,000 employees in San Francisco. This directly impacts that amount of data fetched from the connector itself. And so the sooner we can actually do that, sooner we can actually do the filtering, the less load we actually have on the system, the less compute we use, and the more we enable us to take advantage of our connector indexes here. And so in the case of Pinot, we're able to take advantage of the fact that Pinot has great indexing, Pinot has great performance, and we can really take advantage of that much more with the dynamic filtering. Let's see. Sorry about this. Do we just need to replug this in, or? All right, thanks for your patience. So the next piece here that we worked on was tracing. And so I'll give a quick overview of distributed tracing, but one thing we did was also instrument tracing through OpenTelemetry, which is the open standard for distributed tracing. And so if we take a look at standard observability in Presto, we see that you maybe are using a Presto client of some sort that is ultimately calling the Presto coordinator to perform work on the Presto worker against some storage system. The logs from this maybe go to some collector that ultimately gets surfaced through your observability backend here. And so what that looks like, for example, the Presto client might have a log saying that it's doing a certain query and that there's a query ID associated with that. The Presto coordinator also has some logs saying that, oh, we're currently running this query, or this is the performance of a query. The Presto worker might also have other logs, such as errors that it might incur during execution. But the one thing about this is that for a given query, all of these pieces are isolated. There's no way to connect and say that the same query ID 123 was connected to this out-of-memory error without additional logic in multiple steps. There's no easy way for us to understand what's actually happening throughout our system when we're touching disjoint systems here. And so one thing we contributed to Presto was a Presto OpenTelemetry module, which enables us to begin utilizing OpenTelemetry as standard, pretty much an open standard that allows us to instrument some tracing to unify this. From that, we have to send some other open standard headers to Presto in order for us to utilize, for example, other trace data that may be occurring. So this way we can tie together, for example, queries or other pieces of information tied to the spans that are executing before we actually hit Presto. And ultimately what this looks like is an OpenTelemetry export towards the collector, which many standard observability agents and whatnot will support. And by using this open standard, the previous few logs that we saw, for example, on the Presto client, the coordinator, and the worker are able to be tied together in a way that we can trace from an end-to-end system what's occurring. And in practice, what this looks like for us is that we get really nice flame graphs, being able to trace queries end-to-end, seeing how they're being processed from various parts before, in the purple here, of our internal systems, into how they get propagated through to Presto, and how the query actually executes at each stage. Currently, Presto supports tracing at a very high level, saying when the query is started, when it's being planned, when it's queued, when it's executing, and when it's finished. We hope to contribute more here to get more detailed breakdown into how queries actually run, so that when we do encounter issues or we do encounter bottlenecks, that we understand where and how we can actually tackle them. And so this is something we're really proud of and excited about, and we think that really other people can take advantage of. As, first of all, we're using an OTel standard here that is, a standardized standard and open in a way that really all companies are aware of and can integrate into various different platforms. And this also gives us vendor-agnostic application program sort of integration. And so we use, for example, Datadog internally, but depending on who your vendor is here, OpenTelemetry plays really nicely with those. Some other contributions we made here were to add support in Pinot. And some of those things look like proper null handling, like I mentioned, and big decimal data type support. And through this, we also propagated this up to the Presto ecosystem so that other companies and other people utilizing Presto Pinot are also able to take advantage of again, the benefits of Presto, the ANSI SQL support, alongside some of the really nice benefits of Pinot and the speed of their execution. And so these are some of the contributions we've made in open source that really enable us to have the feature support we needed for our use cases. And yeah, there's a lot more here and more to come. We've contributed, we've done work, for example, supporting Presto on Helm. We've noticed quite a number of bugs in both our Presto and Pinot ecosystems. We've worked with session property support, for example, for the various connectors as well. And so there's a lot more coming from us and that we'd love to contribute and help with the ecosystem. And so a little bit about what was the impact of some of the pieces that we've made here. From moving from our old system, as well as some of the optimizations we've performed, for our particular use cases, we've seen some speedups as fast as 100x in terms of our execution speed, a lot due to, for example, the dynamic filtering in ways that we couldn't filter before. And compared to our old system, I'll say this with an asterisk, we can't query every single piece of data out there, but really we've unlocked a lot more query support for our customers and our products as well. Before we had quite stringent limitations on the number of rows we could ultimately return, the complexity of the queries, the number of tables we could join against. With Presto, we've really unlocked this way for us to support a lot more data at scale in a way that's really horizontally scalable and maintainable. And that's really awesome for our customers as we continue building this platform. So what did we learn through this process? Honestly, there's too much to go over in just a few slides. But a couple lessons I've learned as somebody relatively new to contributing to open source and working with this to really power us internally is making sure to confirm your assumptions. Internally, there's always bugs with your code, but you think, oh, this is a decade-old database, everything must work flawlessly across everything. It's really a wrong assumption. There's definitely specific use cases. There's always various niches and different execution patterns, and also the scope of the project is huge. But to be aware of that and understand that there's a lot of things that can go wrong and will go wrong, but that's okay. And there's a lot of work that's being done to really solidify the system, but to understand really how are we building this system. And for us internally, this meant reevaluating how we were tuning our cluster. We were looking at online recommended, use this many partitions, you do these kind of joins, you do this kind of performance, this to unlock performance. That looked really different for us because of the kinds of use cases we were looking to power, which weren't these giant analytical queries. And so we had to tune the cluster in a way that made sense for us, which really comes down to how do we drive our use cases? When starting with any open source project especially, it can be really overwhelming. The first thing I did was dive into every part of the code and try to run and see what happens. Would not recommend. It's very overwhelming and time consuming. Instead, what I saw was that driving specific use cases. What did we actually need, and how do we get to that? And what changes are necessary to make that happen? Really made it a lot easier to not only make the changes, but to reach out to the community for the support we needed with specific questions and with specific action items that would ultimately help us with our use cases. And lastly, really the open source community with Presto has been fantastic. Here's an XKCD comic on the perpetual struggle with looking for your answers to your questions. And people post about the problems, but sometimes you can never find the answer. And I'm really happy to say with the Presto community, there's a lot of people to thank for this. People have been so open to share how they've approached the problems, the existing limitations of the system, and to really be very generous with their time with us to really aid us in this process. And so I'm very grateful for the Slack community as well as other through GitHub and whatnot that people have really interacted with us. But again, that being said, because the open source community is so strong, anybody can contribute. And it can be from small use cases to big use cases, custom met needs to just existing some bugs. There's a lot of ability to contribute, and Presto has really set a good foundation, as mentioned before this morning, that it is an open standard. It is an open environment, an open ecosystem, and that empowers a lot of individuals to really contribute to this system. I want to give a quick shout out and some acknowledgements. Rohan, thanks again for just reaching out to me about this talk. Really happy to be giving it here. To Tim and James for giving us some guidance around Presto and our PRs. Sean from Pinot and Startree for really working with us in the Pinot connector, as well as Shayan Harrison from our team, our infra team, who really enabled a lot of this to happen. I also want to give a quick shout out to my team, Nizar, who's really done a lot of the work on the Pinot pushdowns and contributions, a really great mentor here to me as well. Alex, my intern, who contributed a lot to the distributed tracing component. He was able to get that PR out for the Presto ecosystem. We're super excited. As well as Daniel for helping us set up the environment to make us quickly code against the Presto code base. So that's really nice. We are hiring, and so I work with a great group of people. So let me know, reach out to me, we can talk after. If you're interested, I can tell you a little bit more about my role. But again, thank you so much for this, your time. Great to be here. My name is Andy Lee. You can find me on LinkedIn. And this talk was customer-facing Presto at Rippling. I'll take any questions. Yeah, absolutely. So just to repeat, the question was around dynamic filtering, how we're going about that process. So dynamic filtering, I remember is, so currently it's an experimental sort of flag you can configure. And so by default, you'll get a lot of the, for example, there's like size limitations, right? You don't necessarily want to dynamically filter across like a million rows, right? You might as well just do the scan or stuff like that. So there are some configurations that you can do for our purposes. The defaults work fine for us. But then in terms of the pushdowns, what we do here is we just work with the connector. And so the connector, we make sure we handle some logic to push down the dynamic filtering logic into the Pinot connector itself. And then everything else comes automatic, essentially, from that point there. I think there is a little bit more we can do in particular cases to handle maybe certain transformations or types of data here, but for the most part, that's sort of how that happens. Sorry, could you, I think there's a microphone here if that works for you.
So my question is, did you evaluate Pinot against any other option?
When we evaluated?
Did you evaluate Pinot against other options?
Sure, yeah. So do you mean like in terms of other databases we were using as, yeah, absolutely. So we did look at Pinot and other options as well. For our purposes, there's a few reasons we went with Pinot. One was that in terms of the work they've been doing on some of the real-time OLAP work, it's very well optimized. There's a lot of areas of optimization that work really well for us in terms of scaling out. As well as our vendor has been super supportive, and we have a very close-knit relationship with them. So we've been really able to get a lot of the feature functionality we need as well. That's at a high level. There's a lot of specifics in comparing. For example, I know in this space, Druid is a very common comparison as well. For our purposes, we believe that Pinot from our tests was a faster, more optimal solution here, if that answers your question. Any other questions?
Hey, Andy, great talk. Great to see an ex-Uber person on the stage as well. I had a question about the data prep for Pinot. So how do you guys get the data into Pinot, and have you looked at Presto as your data prep platform as well?
Yeah, so in terms of getting our data into Pinot, we're mostly just streaming data through Kafka at this point. Of course, subject to evolving depending. We've also been looking at, for example, S3 cold storage on Pinot as well, as something that we'll support for various different use cases. And for the second part of your question around, sorry, what was the second part here?
The data prep part, the transform.
Yeah, so for transformation here, right now, one advantage we have with Pinot, right, is that the Startree index does handle a lot of our use cases here. But we are currently this is kind of the early days, so we are looking at some also transformation of data as well for very competitive, repetitive, materialized queries essentially that we're currently figuring out actually.
Hi. Yeah, for the first part, you were talking about this language that you created. I don't remember the name, RSQL or something like that. It seems it resembles a little bit like a metric store. So I was wondering if you guys look at there are some open source projects around metric stores or commercial alternatives at this point too. So just wondering if you guys look at something like that before making the decision to create your own, or maybe they were not around at that time.
Yeah, sure, absolutely. So our language, RQL, Rippling Query Language, one thing we thought about when we were designing the language was that a lot of our customers who would use it are HR professionals, people who might not have as much knowledge of SQL and stuff like that. And so one thing that creating a custom language does for us is it gives us the power to really make it as user-friendly as possible for non-technical people. And so that's been a really big emphasis of our language as we've built it out and really empowered our customers to use our data platform here. Good question, Joe.
In one of the slides, you showed that coordinators is associated with the Presto open telemetry. So I was just thinking, what is the business use case for that in that case? Like how you use telemetry?
Yeah, so how do we use like the distributed tracing we implemented?
Yeah, and how it turns in the monetization or something related to the business value?
Sure, absolutely. So like I mentioned earlier, like one thing that we struggled with as we tried to adapt Presto to our use case was that it looked a little different from a lot of the high analytical workloads that we saw. And so one thing that distributed tracing actually gives us is insight into how individual queries, we can also partition them. One thing you can do in like tracing is you can attach tags to various different like spans, which is what they're called. And so it's really easy to slice and dice to see for these particular queries, am I spending a lot of time, for example, just queuing it up on runtime, finishing up the query with connectors, as well as debugging various issues that come up. So you can see, for example, which specific query qualities are leading to failures, for example. That is all unlocked with sort of the end-to-end trace because you can pass down tags from your application all the way through the stack. And so that information is all connected together, essentially. And so it's a huge save on developer time as well as optimizing our bottlenecks to sum that up.
How do you transition from RQL to SQL?
Yeah, sure. So we have a lot of work from some of my great coworkers where they do a lot of like logic to handle, for example, sort of the AST for that piece into how that translates into SQL. So there's custom logic that pretty much says like, for these sort of statements and whatnot, like how do you form that into selects, froms, where clauses, et cetera. So there's a good amount, there's a translation phase. It's a pretty massive piece alone on that part as well. Cool, I think we're a little bit past time, but thank you so much again for your time. It was great being here.